You might not think of water as being magnetic, but it is, and so are graphite, aluminum, and glass. This is a new and different category of magnetism called either para or diamagnetism, and it's different from the magnetism that you're used to. You're probably already familiar with ferromagnetism. Ferro means iron. An unmagnetized piece of iron, or nickel, or cobalt becomes a magnet in the presence of a magnetic field. The effect is strong and lasts even after the magnet is removed. Paramagnetism is a similar effect, except that it's much weaker and temporary. Aluminum is a good example of a paramagnet. And so is oxygen, which is attracted to magnets. Here, I have a few milliliters of liquid oxygen, which sticks to the magnet. I'll explain why later. Gadolinium oxide and cupric sulfate are good examples of paramagnetic substances. Cupric sulfate is a salt that can be picked up by a magnet. Diamagnetic materials are exactly the opposite of paramagnetic. They are always repulsed. They would rather die than be in a magnetic field. An important example of a diamagnetic material is graphite. This specially made pyrolytic graphite is repelled by a magnetic field. Don't be confused. This is not static electricity or eddy currents. Graphite is repelled by a magnet, always, both by the north and south end. Pyrolytic graphite is a grown crystal of flat carbon layers which maximizes the diamagnetic effect. Of course, the best diamagnets are superconductors, which at low temperatures provide exact opposite repulsion to whatever magnetic field is present when they're chilled. They are perfect diamagnets. The most famous and powerful diamagnetic is bismuth, element number 83 on the periodic table. The bismuth-powered boat sails toward the weaker magnetic fields. One way to check whether an object is diamagnetic or paramagnetic is to see how it aligns itself in a magnetic field. Diamagnetic objects like glass will rotate to avoid magnets. Here, we see that the glass is diamagnetic because it twists to get to the weaker magnetic field. But aluminum rotates into the field, typical of a paramagnet. On the periodic table, we see that aluminum has 3 valence electrons. So what does it take to understand what it means for something to be a paramagnet or a diamagnet? You have to know what the electrons are doing. Consider, for example, aluminum. We see from the periodic table that aluminum has 3 valence electrons. That's 2s and 1p. Now it's that unpaired electron that makes it a paramagnet. This unpaired electron enables it to become magnetized. And it's that unpaired electron that is free to be magnetized and attracted by the magnet. But what about a diamagnet like water? Yes, the water molecule. It has all of its electrons paired. It will not be magnetized. In fact, water is repelled by a magnetic field. The electrons come to lower energy as they are moved away from the magnet. In conclusion, when something is a paramagnet or a diamagnet, it tells you what its electrons are doing. In the case of a paramagnet, it has at least 1 unpaired electron. In the case of a diamagnet, it has mostly paired electrons.
A diamagnetic substance is feebly repelled by a strong magnet. When placed in a non-uniform magnetic field, these substances move from stronger parts of the field to the weaker parts. For example, when powder of a diamagnetic substance put in a watch glass placed on 2 pole pieces of magnet in such a way that the magnetic field is strong near the sides of the glass plate, You can see that the material shifts towards the center where the magnetic field is weak. Similarly, when we bring the two poles close to each other, the material is shifted towards the ends of the plate, again where the magnetic field is weak. When a specimen of a diamagnetic material is placed in a magnetizing field, the lines of force prefer not to pass through the specimen, as if a diamagnetic substance expels field lines. When a rod of diamagnetic substance is suspended freely in a uniform magnetic field, the rod comes to rest with its longest axis perpendicular to the direction of the applied field, or the shortest axis along the direction of the field. If a diamagnetic liquid, say water, in a U-tube is subjected to a magnetic field, the level of a diamagnetic liquid in U-tube is depressed. Paramagnetic substance is feebly attracted by a strong magnet. When placed in a non-uniform magnetic field, these substances move from weaker parts of the field to the stronger parts. For example, when powder of a diamagnetic substance put in a watch glass placed on two pole pieces of magnet in such a way that the magnetic field is strong near the sides of the glass plate, you can see that the material is shifted towards the ends of the plate, where the magnetic field is strong. Similarly, when we bring the two poles close to each other, the material is shifted towards the center, again where the magnetic field is strong. When a specimen of a paramagnetic material is placed in a magnetizing field, the lines of force prefer to pass through the specimen rather than through air. Thus, magnetic induction inside the sample is more than the magnetic intensity. When a rod of paramagnetic substance is suspended freely in a uniform magnetic field, the rod comes to rest with its longest axis along the direction of the applied field, or the shortest axis is perpendicular to the direction of the field. When a paramagnetic liquid, say solution of copper sulfate, in a U-tube is subjected to a magnetic field, the level of a paramagnetic liquid in U-tube rises. Substances ਇੱਕ weak magnet ਨਾਲ ਵੀ ਆਸਾਨੀ ਨਾਲ strongly attract ਹੋ ਜਾਂਦੇ ਹਨ। Non-uniform magnetic field ਵਿੱਚ ਇਹ field ਦੇ weaker parts ਤੋਂ stronger parts ਵੱਲ move ਕਰ ਜਾਂਦੇ ਹਨ। ਜੇ ਇੱਥੇ ਦੋ magnetic poles ਦੇ ਵਿਚਕਾਰ ਇੱਕ glass plate ਰੱਖੀ ਹੈ ਅਤੇ plate ਵਿੱਚ ferromagnetic substance ਦਾ powder sprinkle ਕੀਤਾ ਜਾਵੇ ਤਾਂ ਤੁਸੀਂ ਦੇਖੋਗੇ ਕਿ ferromagnetic substance plate ਦੀਆਂ sides ਵੱਲ shift ਹੋ ਗਿਆ ਹੈ ਜਿੱਥੇ magnetic field strong ਹੈ। ਜਦੋਂ ਦੋਨੋਂ poles ਇੱਕ ਦੂਜੇ ਦੇ ਨੇੜੇ ਲਿਆਏ ਜਾਂਦੇ ਹਨ ਤਾਂ ਇਹ ਮਟੀਰੀਅਲ ਪਲੇਟ ਦੇ ਸੈਂਟਰ ਵਿੱਚ ਇਕੱਠੇ ਹੋ ਜਾਂਦੇ ਹਨ, ਉੱਥੇ ਹੀ ਜਿੱਥੇ ਮੈਗਨੈਟਿਕ ਫੀਲਡ ਸਟਰੋਂਗ ਹੈ। ਫੈਰੋਮੈਗਨੈਟਿਕ ਮਟੀਰੀਅਲ ਦੇ ਕਿਸੇ ਸਪੈਸੀਮਨ ਨੂੰ ਮੈਗਨੇਟਾਈਜ਼ਿੰਗ ਫੀਲਡ ਵਿੱਚ ਰੱਖਣ ਤੇ ਉਸ ਵਿੱਚ ਲਾਈਨਸ ਆਫ ਫੋਰਸਿਸ ਇਕੱਠੀਆਂ ਹੋ ਜਾਂਦੀਆਂ ਹਨ। ਇਸ ਤਰ੍ਹਾਂ ਸਪੈਸੀਮਨ ਦੇ ਅੰਦਰ ਮੈਗਨੈਟਿਕ ਇੰਟੈਂਸਿਟੀ ਨਾਲੋਂ ਮੈਗਨੈਟਿਕ ਇੰਡਕਸ਼ਨ ਕਿਤੇ ਜ਼ਿਆਦਾ ਹੋ ਜਾਂਦੀ ਹੈ। ਜੇ ਫੈਰੋਮੈਗਨੈਟਿਕ ਸਬਸਟੈਂਸ ਦੀ ਇੱਕ ਰੋਡ ਯੂਨੀਫਾਰਮ ਮੈਗਨੈਟਿਕ ਫੀਲਡ ਵਿੱਚ ਫ੍ਰੀਲੀ ਸਸਪੈਂਡ ਕੀਤੀ ਜਾਵੇ ਤਾਂ ਰੋਡ ਦੀ ਲੌਂਗੈਸਟ ਐਕਸਿਸ ਦੀ ਰੈਸਟ ਦੀ ਡਾਇਰੈਕਸ਼ਨ ਅਪਲਾਈਡ ਫੀਲਡ ਦੀ ਡਾਇਰੈਕਸ਼ਨ ਵਿੱਚ ਹੁੰਦੀ ਹੈ ਤੇ ਰੋਡ ਦੀ ਸ਼ਾਰਟੈਸਟ ਐਕਸਿਸ ਦੀ ਰੈਸਟ ਦੀ ਡਾਇਰੈਕਸ਼ਨ ਅਪਲਾਈਡ ਫੀਲਡ ਦੇ ਪਰਪੈਂਡੀਕੁਲਰ ਡਾਇਰੈਕਸ਼ਨ ਵਿੱਚ ਹੁੰਦੀ ਹੈ। ਜੇ ਇੱਕ ਯੂ ਟਿਊਬ ਅੰਦਰ ਕੋਈ ਫੈਰੋਮੈਗਨੈਟਿਕ ਲਿਕੁਇਡ ਮੈਗਨੈਟਿਕ ਫੀਲਡ ਵਿੱਚ ਰੱਖਿਆ ਜਾਂਦਾ ਹੈ ਤਾਂ ਯੂ ਟਿਊਬ ਵਿੱਚ ਲਿਕੁਇਡ ਬੜੀ ਤੇਜ਼ੀ ਨਾਲ ਰਾਈਜ਼ ਕਰਦਾ ਹੈ